The evolution of the wolf occurred over a geologic time scale of 800,000 years, transforming the first Middle Pleistocene wolf specimen that is recognized as being morphologically similar to Canis lupus into today's dog, dingo and gray wolf. Ecological factors including habitat type, climate, prey specialization and predatory competition has greatly influenced the wolf's genetic population structure and cranio-dental plasticity. Wolves went through population bottleneck 20,000 years before present, which indicates that many wolf populations had gone extinct at a time that coincided with the last glacial maximum and the expansion of modern humans worldwide with the technology for capturing large game. The domestic dog is the most widely abundant large carnivore and a descendant from one of those now extinct wolf populations. Today, the wolf is represented by the many extant subspecies of Canis lupus, which includes the dog and dingo. Fossil record. Further information. Evolution of Canis and canid relationships. The fossil record for ancient vertebrates is composed of rarely occurring fragments from which it is often impossible to obtain genetic material. Researchers are limited to morphologic analysis, but it is difficult to estimate the intraspecies and interspecies variations and relationships that existed between specimens across time and place. Some observations are debated by researchers who do not always agree, and hypotheses that are supported by some authors are challenged by others. There is general agreement on the most ancient record, which shows that feliforms and caniforms emerged within the superfamily Carnivora Morpha 43 million years before present. The caniforms included the fox-like Leptocene genus, whose various species existed from 34 million YBP before branching 11.9 million YBP into Vulpes and Canini. The jackal-sized Eucyon existed in North America from 10 million YBP, and by the early Pliocene about 6 to 5 million YBP. The coyote-like Eucyon C. invaded Eurasia. In North America it gave rise to early Canis, which first appeared in the Miocene in southwestern US and Mexico. By 5 million YBP the larger Canis lepophagus appeared in the same region. The canids that had immigrated from North America to Eurasia, Eucyon, Vulpes, and Nyctereutes, were small to medium-sized predators during the late Miocene and early Pliocene, but they were not the top predators. The position of the canids would change with the arrival of Canis to become a dominant predator across the whole Arctic. The wolf-sized C. Chiphilensis appeared in northern China in the mid-Pliocene around 4 to 3 million YBP. This was followed by an explosion of Canis evolution across Eurasia in the early Pleistocene around 1.8 million YBP in what is commonly referred to as the wolf event. It is associated with the formation of the Mammoth Steppe and continental glaciation. Canis spread to Europe in the forms of C. arnensis, C. etruscus, and C. falconeri. The fossil record is incomplete, but it is likely that wolves arose from a population of small, early canids. Morphological evidence and genetic evidence both suggest that wolves evolved during the Pliocene and early Pleistocene eras from the same lineage. That also led to the coyote, with fossil specimens indicating that the coyote and the wolf diverged from a common ancestor 1.5 million years ago. The ancestor of the jackal and the other extant members of the Canis genus had split from the lineage before this time. After this separation from a common ancestor, the species that were believed to be involved in the further evolution of the wolf and coyote and the beliefs of some paleontologists diverged. A number of researchers believe that the lines of C. priscolatrans, C. etruscus, C. rufus and C. lupus were components involved in some way that lead to the modern wolf and coyote. Canis lepophagus. Canis lepophagus lived in the early Pliocene in North America. Curtin proposed that the Blancan C. lepophagus derived from smaller Miocene Canis species in North America. It then became widespread across Eurasia, where it was either identical to or closely related with Canis of Europe. Johnston describes C. lepophagus as having a more slender skull and skeleton than in the modern coyote. Novak found that the early populations had small, delicate and narrowly proportioned skulls that resemble small coyotes and appear to be ancestral to C. latrans. Johnson noted that some specimens found in Cedar Canyon, Texas had larger, broader skulls, and along with other fragments Novak suggested that these were evolving into wolves. Tedford disagreed with previous authors and found that its cranio-dental morphology lacked some characteristics that are shared by C. lupus and C. latrans, and therefore there was not a close relationship, but it did suggest C. lepophagus was the ancestor of both wolves and coyotes. Canis priscolatrans. Canis priscolatrans lived in the late Pliocene, early Pleistocene in North America. The first definite wolf appeared in the late Blancan, early Irvingtonian, and named C. priscolatrans that was either very close to or a synonym for Canis edwardi. It resembled C. rufus in cranial size and proportions but with more complex dentition. However, there are no fossils of C. rufus until the late Rancalabrian. Curtin was uncertain if C. priscolatrans derived from C. lepophagus and C. onensis, but believed that C. priscolatrans was a population of large coyotes that were ancestral to Rancalabrian and recent C. latrans. He noted that C. onensis of Europe showed striking similarities to C. priscolatrans, and they could represent what once was a Holarctic population of coyotes. Novak disagreed, and believed that C. priscolatrans was a counterpart to the European C. etruscus. Curtin later proposed that both C. priscolatrans and C. etruscus were part of a group which led to C. lupus, but was not sure if they evolved separately from C. lepophagus or a possible common ancestor that was derived from C. lepophagus. The remains of the larger coyote-like Canis edwardi have been found in the later Pliocene in the southwestern USA along with C. lepophagus, which indicates a descent. Tedford recognized C. edwardi and found that the cranio-dental morphology of C. priscolatrans fell inside that of C. edwardi such that the species name C. priscolatrans was doubtful. Canis ambrusteri, Middle Pleistocene in North America. The North American wolves became larger, with toothed specimens indicating that C. priscolatrans diverged into the large wolf C. ambrusteri. Martin disagreed, and believed that C. ambrusteri was C. lupus. Novak disagreed with Martin and proposed that C. ambrusteri was not related to C. lupus but C. priscolatrans, which then gave rise to C. dirus. Tedford proposed that the South American C. gezi and C. neringi share dental and cranial similarities developed for hypercarnivory, suggesting C. ambrusteri was the common ancestor of C. gezi, C. neringi, and C. dirus. Canis dirus. Canis dirus lived in the late Pleistocene to early Holocene in North and South America. C. dirus was the largest of all Canis species. Golet disagreed with Novak and agreed with Martin, and proposed that the dire wolf C. dirus was a variant of C. lupus. Novak, Curtin and Berta disagreed with Golet and proposed that C. dirus was not derived from C. lupus. The three noted paleontologists Xiaoming Wang, R. H. Tedford and R. M. Novak have all proposed that C. dirus had evolved from C. ambrusteri, with Novak stating that there were specimens from Cumberland Cave, Maryland that indicated C. ambrusteri diverging into C. dirus. The two taxa share a number of characteristics, which suggests an origin of C. dirus in the late Irvingtonian in the open terrain in the mid-continent, and then later expanding eastward and displacing its ancestor C. ambrosderi. Canis mosbarkensis. Canis mosbarkensis lived in the Middle to Late Pleistocene in Eurasia. The holotype of the mossback wolf C. mosbarkensis was found in Jokgrim. In 2010, a study found that the diversity of the Canis group decreased by the end of the early Pleistocene to Middle Pleistocene and was limited in Eurasia to the small wolves of the C. mosbarkensis C. variabilis group that were a comparable size to the extant Canis lupus palipes, and the large hypercarnivorous Canis lysaunoides that was comparable in size to extant northern grey wolves. C. mosbarkensis occurred between C. etruscus in the early Pleistocene and the modern C. lupus. C. mosbarkensis was smaller than most North American wolf populations and smaller than C. rufus, and has been described by Curtin as being similar in size to Canis papals. As wolves continue to evolve, they become bigger. It was still living in Europe at a time coinciding with the North American early Ranklebrian and had grown in size by the late Ranklebrian. Novak proposed that C. mosbarkensis was the ancestor of Eurasian and North American wolves, and that one population of C. mosbarkensis invaded North America where it became isolated by the later glaciation and gave rise to C. rufus. Another population of C. mosbarkensis remained in Eurasia and evolved into C. lupus, from where it invaded North America. Tedford compared C. mosbarkensis with C. variabilis as they both existed in the Middle Pleistocene across mid-latitude Eurasia. The only difference was that C. variabilis had nasal bones that terminated or anterior to the most posterior position of the frontal maxillary suture, and therefore these two taxa could represent variation in the one geographically widespread mid-Pleistocene wolf. The phylogenetic descent of the extant wolf C. lupus from C. etruscus through C. mosbarkensis is widely accepted. Lumley considered C. mosbarkensis to be a subspecies of the grey wolf and proposed a name of C. lupus mosbarkensis. However, other researchers propose that they can see no clear anatomical relationship between C. mosbarkensis and C. etruscus, and that it is more similar to C. arnensis, and that it exhibits a size and dentition more similar to an omnivorous jackal. Alternate proposal. Wang and Tedford proposed that the genus Canis was the descendant of the coyote like UC and Deva. C. in its remains first appeared in the Miocene in southwestern USA and Mexico. By the Pliocene, the larger Canis lepophagus appeared in the same region, and by the early Pleistocene Canis latrans was in existence. They proposed that the progression from UC and Deva C to C. lepophagus to the coyote was linear evolution. Additionally, C. edwardi, C. latrans and C. aureus form together a small clade, and because C. edwardi appeared earliest spanning the mid-Blancan to the close of the Irvingtonian, it is proposed as the ancestor. Novak and Tedford also believed that it was possible for C. lupus to have been derived from a Miocene or Pliocene canid line that preceded and was separate from C. lepophagus. Wang and Tedford proposed that assuming the geological attribution of the material was correct, then the earliest identifiable C. lupus remains date 800,000 YBP, with wolves similar to the living species occurring in both the Silurian fauna and in the Cripple Creek sump fauna, which points to an origin of these wolves in Beringia. Based on morphology from China, the Pliocene wolf C. Chileensis may have been the ancestor for both C. ambrusteri and C. lupus before the migration into North America. C. ambrusteri appeared in North America in the Middle Pleistocene and is a wolf-like form larger than any Canis at the time. At the end of the most recent glacial retreat 30,000 YBP, warming melted the glacial barriers across northern Canada, allowing Arctic mammals to extend the range into mid-latitude North America, including elk, caribou, bison, and the gray wolf. In Eurasia during the Middle Pleistocene, C. falconeri gave rise to the hypercarnivore genus Senecio, which then gave rise to genus Cuon and genus Lycon. Just before the appearance of C. dirus, North America was invaded by genus Senecio that was as large as C. dirus and more hypercarnivorous. The fossil record shows them as rare, and it is assumed that they could not compete with the newly derived C. dirus. The large wolf C. antonii from late Pliocene to early Pleistocene China was assessed as being a variation within C. Chileensis, and the large wolf C. falconeri occurred abruptly in Europe in the early Pleistocene, perhaps representing a westward extension of C. antonii.